Yeah. Then we are trying to just, use this, problem, okay, to see what is the spring constants, okay. How we can solve this problem? So what do you think? When the object is compressed, okay, so the spring is compressed, what kind of energy we have? Elastic potential energy. Yes, okay. I just changed the color. Okay, I say we have elastic potential energy. Okay, and elastic potential energy is 1 over 2 kx squared. Good. Okay. So can I calculate the elastic potential energy value? Okay. We have the x. Yes. Do we have the k? No. Okay. We don't have the K. Yes. Okay. What we do, it means that we cannot calculate the energy here. Okay. We need to find the K first. Okay. But we know that this energy will be transferred to the ball. Okay. And ball will get what kind of energy? Kinetic energy. Energy is conserved. Good. Kinetic energy is transforming from one situation to another situation. Good. Okay. So when the ball was on the top, okay, so what kind of energy it does have? Yes, on the top. Plus the kinetic energy. Yes. Okay. Good. Okay. So just do this. Okay. This is where the ball is compressed. Yes. The ball is compressed the spring. Good, good. So we are telling that when the ball has been compressed with the spring, okay, what kind of energy we have? Elastic potential plus gravitational potential, yes? Which is mgh. Good? Okay, let me just explain. This is compressed, yes? How much? 0.15 meter, yes? And it is here. Good? And then when it's released, okay, so it's gonna be here, yes, the ball. Good. This is situation number one. Good. This is situation number two, yes. At situation number two, okay, the spring back to its normal position. Make sense? Okay. So I'm gonna ask you the energy of the ball at situation number one. What kind of energy we have? Elastic, because the spring is compressed, yes. Elastic, I call it US plus UG. Why? Because, no, no, because it's above the ground. Compress is elastic potential energy. UG, which is MGH, is the potential. Yes, it is because, good. Okay, so, because not only this is compressed, okay, but also it is above the ground, yes? Okay, that's why, at situation number one, not only we have elastic potential energy is saved, okay, in the ball, okay? Plus the ball is above the ground. Good. So I just write it down. 1 over 2 kx squared, yes, plus mgh. What is the h? H is here. Good. At situation number two, what kind of energy we have? Kinetic and again, is it still above the ground? Yes. UG plus kinetic energy. Good. Because this is the situation when it is released from the spring. Yes. Make sense? It is the situation when it is released from the spring. Good. Okay. So what kind of energy we have? So again, mgh, yes, plus 1/2 mv squared. Good. Okay. But again, I call it number two. Okay. Velocity at number two. Okay. It does have velocity. Yes. V2. Good. Make sense? I call this situation number three. Okay. When the ball reached the ground or hit the ground. Okay. Can you tell me what kind of energy we have at number three? At
Are we considering it just before it hits?
no, yeah, just before it hits. Yes.
So how can that be?
Perfect. 1/2 m. Now the velocity at 3, yes? Because the velocity is going to be different. Okay, I call this v3 squared plus.
Would we still? I don't know.
Relax. Think about it. You have time. I can wait until tomorrow. Okay.
Potential energy?
Why potential energy?
No, it's still.
What is the potential energy? We consider the ground as a reference for potential energy. When the object is above the ground, okay, it has potential energy. But when it's on the ground, there is no potential energy. So the potential energy is zero. Yes? Make sense? Do we have any other energy? No.
So it's just that.
That's sad. So how many equations we have right now? Oh, are you okay? You ta-
Caught it in time. Just still talking.
Good. So what do you think? We have three equations, yes? Okay. And this equation, okay, it's kind of representing the energy. Okay. Good. So energy at situation number two, one is going to be equal energy as a situation number two. Yes. Energy equals situation number three. Why? Because there is no dissipative force. When there is no dissipative force, energy is conserved. Okay. So I can say energy at situation number one, yes, equal energy at situation number two, energy at situation number three. Good. I put these two 2 by 2 equal each other. E1 equal E2, yes? And E2 equal E3. Or even you can just say E1 equal E3, yes? Can we do this? Okay. What is the energy at 1? 1/2 k x squared plus mgh, yes? What is the energy at 2? Just kinetic energy, yes? Okay. Kinetic energy and potential energy. mgh, yes, plus 1/2 m velocity square power of 2. What happened here? Cancel each other, yes? Good. So from here, what you can get, what is the E2? mgh, yes, plus 1/2 m velocity squared power of 2 equal, what is the E3? 1/2 m velocity squared.
It would just be energy.
Yes. Okay. E3, I'm just writing, okay, because I already have these, okay? I'm just putting them equal to each other, okay? To see which one can help me to find the K value. Make sense? Okay. What is the last one? E1 equal E3. What is the E1? 1/2 K x squared plus mgh equal what? 1/2 m velocity 3 squared. Good. Which one of these can help you to find the, because we have mass, yes? What is the mass? 35 gram, which is 0.035 kilogram, yes? We have height. What is the height? 1.7 meter. We have range, yes? It is 4 meter. Okay. Do we have V2? No. Do we have V3? No. Okay. So, and when, okay, let's look at the first one. I don't have K, yes, I don't have V2. I cannot use this equation, yes? Look at the number, the next one. Do I have V2? No. Do I have V3? No. I cannot use this equation, okay? You know, I'm just trying to put all possible equation equal to each other, okay? So, I don't want you to feel that, okay, why you are just putting this equal to last one, okay? No, we can put every energy at each situation equal to each other, yes? How about the last one? K is unknown, yes? V3 is unknown. No. How? Because we are not going to get anything, okay? Because if I just solve V3 here and I plug it here, okay, good. I will have V2 unknown and K unknown. Again, there will be two. Oh, but I would say, there you go. I have X equal 4. You know, you remember when the ball was here, when it's released from the spring, yes? When it's released from the spring, no attached to spring, yes? It does have V2 velocity, and it goes and hit the ground. There you go. Hit the ground, yes? And then I have X equal 4 meter. Can I calculate the velocity? There you go. There you go. Okay, because I have height, yes, 1.7 meter. I have range, yes? You remember YF equal YI plus VIYT plus 1 over 2 AYT squared, yes? And in the y-axis, yes, in the y-axis. In the x-axis, yes, what was that? XF equal XI plus VIX delta T, yes?
Would be 0, 1.7.
Okay, tell me. Can you tell me what is the, you know, let's say this is a coordinate system, yes? Okay, this is the origin. What is the YF? What is the YI? Perfect. What is the VI in the X, in the Y direction?
Would it be 0?
Perfect. Because this is the velocity, horizontal velocity. Okay, that's the velocity that we have. Okay, good. The vertical velocity is 0. There you go. Plus 1 over 2. What is the acceleration? Negative 9.8. Yes? Because when it's released, okay, it's going to be the gravitational acceleration. Make sense? Negative 9.8 t squared. Good. Okay. I can find the t from here. Yes. Okay. So let me just change the color.
I was just
So it's going to be negative 1.7 equal 1 over 2 negative 9.8 t squared. Yes. So t is going to be, you know, negative, negative, they cancel each other. Yes. So it's going to be 2 times 1.7 divided by 9.8 square root. Yes.
which is I believe
Make sure, you know, 2 times 1.7. Good. Okay, let me just calculate it here. Okay. So
That makes sense. Yeah.
did you calculate the time?
I got 0.
So let me, I'll calculate it by myself as well. Okay, 2 times 1.7, okay, divided by 9.8, yes? And take the square root of this, yes? Second, square root, second answer. Good. What did you get? Okay, 0.589. Okay, I just rounded to the 2 decimal places. Okay, it's gonna be 0.59 second. Good. I go back to my problem. Okay, so here, you see, what is the XF? What is the 4 meter? What is the XI? 0. What is the initial velocity? V2, yes? In the x-axis, yes? This is the initial velocity in the x-axis. V2 time, what is the time? How long does 0.59, yes? So V2 is gonna be 4 divided 0.59. Okay, calculate this value.
6.7 minus 6.8.
6.8 meter per second. Oh, there you go. 6.8 meter per second. Okay? Now go back to your problem. Okay, to these equation. Okay, which one is helpful to find the K? Let's start with the first one. The first one, because these two cancel each other, yes? What is left? 1 over 2 kx squared equal 1 over 2. And I just calculated we do, yes? So what I do here, 1 over 2, 1 over 2 cancel each other. And k is gonna be m velocity squared power of 2 divided by x squared, yes? Do I have m? Yes, 0.035, yes? Do I have velocity? Good, okay, what was the velocity which I calculated?
6.8.
6.8 power of 2, yes? Divided by x squared. What is the x? 0.17, yes? Power of 2. This is gonna be the spring constant, good?
Just 56.
How much? 56 Newton per meter, yes? Okay. So in this problem, okay, so we have a hockey puck, yes? And the velocity of the hockey puck, okay, so it is, let me just change the color, 5.5 meter per second, yes? What is the velocity of this? The B, 0, yes? These will get velocity, let's call VA, yes? This will get velocity VB. Good? Okay, after the collision. Okay, so it's telling what is the final speed of puck A and puck B. Puck A and puck B. What is the final speed of puck A and puck B? And is this an elastic collision? Let's find out. Okay, so you know what is the energy? Sorry, what is the momentum before collision? You know, this is a before collision, yes?
I got 0.1.
Okay. I call it P, yes, momentum. I for B. What is it? What is the momentum before for B?
Wouldn't it be 0?
0. What is the momentum for A?
0.137.
Okay, what did you do? You just multiplied mass by time velocity. Okay, what is the mass? 0.05 time 5.5. Okay, when you multiply this number, what number did you get?
Wait, that one is 0.025 for the mass.
Oh, mass, there you go, my bad. 2.5. Okay, when you multiply, what number did you get?
0.1375.
0.1375. Okay, so what is the momentum before the collision? Okay, you added these two, yes? Okay, the momentum before is gonna be 0.1375. But what is the momentum before? It is in x-axis or y-axis? X-axis. So we just write momentum before, or let me just change like this. Momentum before I, yes, in x-axis is this. Momentum before in y-axis is 0. Good. Oh, there you go. Why? Because after collision there are two-dimensional motion, yes? Okay. So tell me, okay, so momentum for after, for A. Good. Mass of A time velocity of A. But, this is a two-dimensional, yes? We can say the velocity have two component, AX, yes? AY, good. And then the same thing for B. VBX, yes? VBY. We already know what is the VBX and VBY. Okay, so what is the VAX? Okay, it's gonna be velocity in A, yes, time cosine 65 degree, yes. What is the VAY? Velocity A time sine 65 degree. Good. How about this one? VB, yes. What is the angle? Cosine 37, yes. What is the velocity in the y-axis? Is going to be perfect. VB sine 37 degree. Good. Okay. So what I do here, when I am just writing out, okay, the momentum of the A final, I need to add X, yes. And then I need to add P, F, A, M, A, V, A. What it is? Y. Y. Yes? Okay. What is the mass of A?
0.025.
What is the velocity of A in x-axis? VA, yes. Cosine 65. Good. Cosine 65. Okay. Equal. The next one. What is the mass of what is the mass of A again? 0.025, yes. What is the velocity? In the y-axis is positive, yes, because it's upward. Okay, it's gonna be VA, yes. Sine 65. Good. Okay, let me just separate these. Okay. So tell me, what are these two? Okay, so I'm gonna write PFB, yes. It's gonna be MBVB, good. PFB equal MBVB, yes. What is the first one? X-axis, x-axis. What is the second one? Y. Okay, so what I do here, I'll just write it down like, okay, what was the mass of B? 0.05. Okay, good. What is the velocity of B in x-axis? Is going to be positive, yes, because again, it's still into the right direction. VB, yes, cosine 37 degree equal. Okay, what is the mass of B again? Time. Perfect. Why negative? Because it's moved downward. Okay. So I put this negative here. Okay. Okay. It's going to be VB sine 37. Okay. So interesting. Okay. So you remember, my bad. You remember we had conservation of momentum? Let me just change the color to the white. Okay. Now, PI, good, should be equal PF. Vector. But when it's become two dimension, yes, I just break this down, yes, okay. I just write PIX equal PFX, yes. P initial equal P final in x-axis. P initial in y-axis equal P final in y-axis. Good? Okay, I do have P initial. Let me just change the color. I do have P initial in x-axis. Perfect. P initial in x-axis. I just write it down. 0.1375. Good? Equal to. But what is the P final in the y-axis? I have two P final. Sorry, P final in the x-axis. Okay, I have two, yes? One. Perfect. Just the x one. Add them together, okay? This is the first one, yes? This is the second one. Good? Okay. So add 1 and 2 together. Good? So it's going to be what? So just write it down. 0.025 VA cosine 65 plus 0.05, yes? BB cosine 37. Make sense? Right. So tell me, what is the momentum? 0, see? 0 equal to. Now add them the y and y, yes? 3 and 4 together. Okay, 1 is positive, yes? 0.025 VA sine 65, yes? And when you add, okay, there is a negative here, yes? Okay, it's gonna be negative 0.05 BB, good? Sine 37, okay? Okay, how many equation, how many variable? Two variable, two equation, good? So, easy peasy. You can solve for one, plug it to another one. Okay, which one do you want to solve? Okay, so we are done with physics. Okay, the rest is just the algebra. Okay, so because we just applied Newton, sorry, we just applied conservation of momentum. Yes.
Not sure which one would be.
I think it's better use this one. Okay, so because we can solve for B or A. Okay, what I do? Okay, let me just change my color. So you see here, 0.025. Yes, BA sine 65 equal 0.05, yes? VB sine 37. Good? Which one do you want to solve? Okay, I just solve for B, for instance. Okay, if I want to solve for B, what I do? I divide both sides by 0.05 sine 37, yes? 0.05, good? Sine 37, good? Okay, what happened here? Sine 37 and these cancel each other. What is left is gonna be BB. Okay, try to solve this. Okay, so it's gonna be 0.025 divided by 0.05 sine 65 divided by sine 37. Yes, VA. Good. VB is gonna be what? Okay, 0.025 divided by 0.05 multiplied by parentheses sine of 65 divided by sine of 37. Yes, calculate. What is the value that you get? You got the same value? 7. Okay, so I just rounded to 2 decimal places. It's going to be 0.75 VA. Good. Okay, what you do, you just plug these two here. Yes. So 0.1375 equal 0.025 cosine 65 VA plus 0.05 cosine 37. Yes. Instead of VB, yes, I just plug 0.75 VA. Yes. So what I do, I factor VA. Yes. It's going to be 0.1375. When you factor VA, it's going to be 0.025 cosine 65 plus 0.05 times 0.75 times cosine 37. Okay? So what happened to the VA? VA is going to be 0.1375 divided by 0.025 cosine 65 plus 0.05 times 0.75 times cosine 37. Good? So 0.1375 divided by parentheses 0.025 cosine 65 plus 0.05 times 0.75 times cosine 37, close the parentheses. What did you get? Same thing, okay. VA is gonna be
3.39 meters.
3.39. 3.39 meter per second. Good. What is the VB? VB is gonna be 0.75 times VA, yes? 3.39, which will be time 0.75 will be almost 2.55, yes? VB will be 2.55 meter per second. Good? Okay. So we are done with part A and B. Okay. But what is the part, you see, you go back here, part B, is this elastic collision or no? We,
Is elastic when they stick together?
no, it is when it stick together, okay, it's a perfectly inelastic. It means that the energy is not conserved. But when it's elastic, it means that the energy is conserved. Energy before should be equal energy after. Okay. Yes. If what was the energy before? Just this one have energy, yes? 1/2. What was the mass of A? 0.025 times velocity square, 5.5 power of 2. This is the energy before, yes? What is the energy after? It's going to be, both will have velocity, good? And we already calculated the velocity. Okay, so what is the velocity for each one? One was 3.39, VA 3.39, yes? And then the other one 2.55, yes? VB is 2.55. So calculate the E final. E final is going to be 1/2 mass of the first one, 0.025 times 3.39 power of 2 plus the energy of the second one, which is going to be 1/2 0.05 times 2.55 power of 2, yes? So calculate this value. It's going to be almost same, yes? Because elastic collision, the energy should be conserved. Calculate the EI first and then EF. See how much. Okay. Time.
0.14 plus 0.16.
What did you get for the first one? Energy. You got this number? 0.39, yes? 0.39 joule. 0.39 joule. Okay, let's do the second one. Okay, I'll just say 0.5 times 0.025 times 3.39 power of 2. Okay, so let's see what this happened. Okay, so I'll calculate the second one. 0.5 times 0.05 times 2.55 power of 2. 2.55 power of 2. Okay, and I'm supposed to add these two. This plus this, yes, equal to, you know, 0.
I got that.
Yeah, E total is gonna be what? E final is gonna be 0.3. Okay, 1, yes? You know, if we round it, if we round it to, okay, so it means that the energy is not conserved. Okay, so you know there is a little difference. Okay, so it is not elastic then. Okay, so energy is being lost. Good. Okay, so because you see this one EI is 0.39, EF is 0.31. How much? There is a difference, yes? So energy is lost. What happened to that energy? That energy transformed to the thermal energy. Good. And released to the environment. Good. So the question says, is this elastic? We say no. Why? Because energy is not conserved. Okay, energy is lost. Okay, if it was almost 0.39, okay, so we would say energy is saved. Okay, so energy is conserved, not saved. Okay, so
So like, let's say it was the number I got,
it was exact.
0.389. Would that be?
Oh my, yes, close enough. Yes, okay, but here is big difference. You know, that one is almost zero point 0.4. Okay, and this is 0.3. Okay, zero point 0.1 joule difference almost. Good. So great. So when that person released from the top, okay, what kind of energy we have?
Potential.
Potential. Okay, let me just write it down. Okay, it's gonna be mgh, yes? When the person is here, you know, when the person is here, it does have velocity, good? It's gonna be 1 over 2 m velocity squared, but it is still above the ground, yes? Above the water, okay? So it's gonna be mg this h. This is the energy at this, you know, situation number 1, E1, again, E2. But when it's hitting the ground, let's say here, not the ground, water. It's on the water, yes? Okay. Energy 3. What is the energy 3? Just 1 over 2 m velocity at 3, yes? Let's call these 2, let's call these 3, yes? Because when hitting the water, okay, it does have velocity. Make sense? Okay. So, you know, energy here should be equal energy here, it should be equal energy here. Okay. Choose the surface of water as a reference. Okay, we just did this. Okay, we just choose the water as a, but it's telling that what we are supposed to find the height of H. Good. This H. So it means that you are supposed to plot these two equal to each other to find the H, yes? E2 equal E3. But when you plug it equal to each other, there are two on, there you go. It means that you need to go back, you know, this information about 5.5 second. This is the kinematic information. This is related to the kinematic, okay? This information can help me probably find one of those velocity. Good? Okay, go to see what you can do, okay? So then we will. Here it's telling that, okay, let me just make this bigger. It's telling that how many seconds it takes to reach the ground. It takes 0.5 second, yes? 0.5 second?
Yes.
Delta T is 0.5 second. Okay, so let's say this is the, you know, coordinate system, X and Y, good? Okay, so this is initial, this is final, okay, where it's land. YF equal YI plus BIY, yes? Good. T plus 1 over 2 AYT squared. What is the yi? Yf, 0, yes? On the water, when it's on the water. What is the yi? Height, plus. What is the velocity in y direction? 0 in y direction. That person, no, it is moving. Okay, this person has velocity in this direction, not y direction. Okay, it's a slide. Okay, reach to the bottom. Okay, the velocity is going to be horizontal. At that end, okay, there is no vertical velocity. Okay, so this part is going to be 0. Yes, makes sense. 0 plus 1 over 2, negative 9.8. How many seconds it takes to reach the ground, to the water, to the surface of water? 0.5 seconds. Yes. It was 0.5 or 0.53? 0.5, yes. 0.5 second, power of 2, yes? Okay, you can calculate the height here. Yes? Okay, negative h equal 1 over 2, negative 9.8, 0.5 power of 2, yes? So, what is the h here? 1 over 2, 9.8, 0.5 power of 2. What did you get? 1.225 meter, yes? Okay, if you back to this equation, okay, I found the h. Do I have velocity in v2? You see, go back to the equation here, you see. Do I have v2? No. Yes. Do I have v3? No. How can I calculate the v3 or v2? One of them. Okay, I just
I will put it into the velocity equation where change it x and change it to.
you have two set of equation, okay? In the x-axis, yes, in the y-axis. In the y-axis is the gravitational, okay? In the x-axis, because it's going to be projectile, like a projectile. In x-axis, the acceleration is 0, yes? So it means that we have xf equal xi plus vix times delta t. Good? In the y-axis, we have three equations. Yf equal yi plus viyt plus 1 over 2 ayt squared, okay? What is the other equation? Vfy equal viy plus ayt. Good. What is the last one? Vf final squared, v initial squared, yes, equal 2ay yf minus yi. So, you can calculate the v3, yes, because v3 is in this direction, yes. When the person move on the air, yes, it goes down, yes. You see here, I can say v3 is squared here. See, what is the v initial in the y-axis here? There is no v initial in y-axis. Good. 0, 2, acceleration negative 9.8. What is the y final? 0. What is the y initial? We just calculated, yes? Height. It is going to be 1.252. 225, yes? There you go. I calculate the velocity in 3, yes? Okay? Make sense? I'm just using this formula, good, to calculate the velocity at this point. Let me just erase here. See here, the person was here, yes? What kind of velocity have at situation number 2? It just have velocity in this direction, good? it has a projectile motion and hit the ground, hit the water here, yes? What is the velocity of that person when hit the water in this direction? Good. So here the person has horizontal velocity, good. Here the person has vertical velocity. Okay? We call these V3, we call these V2. Good? Situation number 2. I know height, yes? I can use this equation to calculate the V3. Okay? Because I just calculate the height, yes? Make sense?
Yeah. I guess.
So I just say V3 is going to be a square root of 2 times 9.8 times 1.225. If I calculate this value, 2 times 9.8 times 1.225. What I get, 24, but I need to find the square root. Square root of answer. I get 4.9. Good? You got the 4.9? 4.9 meter per second.
Split it. Yeah, 4.9.
4.9 meter per second. There you go. You remember those equations that I wrote here? I will rewrite one more time. So E2 was mgh plus 1 over 2 m velocity square power of 2. And at situation number 3, energy is 1 over 2 m velocity 3 squared. Good? So I would like to calculate the height, yes? What I do? You can just say E1 equal E2. You can say E1 equal E3. You can say E2 equal E3. Okay, which one you can use? If I want to calculate the height, the bigger height.
2.
E2, okay, it means that I need to do one more calculation, okay, to find E2. Okay, just plug E1 equal E3, yes, because I just found velocity 3 squared, yes? Okay, use this one. E1 equal E3. What is the E1? mgh, yes? What is the E3? 1 over 2 m velocity 3 squared, good? M and M cancel each other, so H is gonna be V3 squared over 2G. So we just find the V3, which is 4.9 power of 2 divided by 2 times 9.8. Good. So I have 4.9 already. I just powered it to 2. Okay. And then I will divide it by 2 times 9.8. It's going to be 1 point.
Is that not the wrong height?
Oh,
We're trying to find the bottom height.
the bottom height? Okay, why it's become exactly equal? So are you sure that when you calculated this, okay, you got 1.225? I didn't check your calculation here. Are you sure that you're... So let me just recalculate this, okay. 0.5 times 9.8 time.
It was 4.0.
Okay. Which one was 4.9? No, I'm just calculating this height. Okay, so the height that we just calculated here.
I got 1 point.
Okay, but we are getting the same value, same answer for the capital H. Okay, let me just,
It's just that the E1 equation, it's using capital H.
yes.
So if we're trying to find
We are trying to find the, which one?
lowercase,
Oh, we are trying to find the lowercase?
because we already did B, we're trying to do A.
No, we were trying to find the A first. We did find the A first, you know? This is the A. Good?
Oh, okay. Maybe
We are getting the same answer. Okay, so I don't know why. Okay, so which is impossible. Okay, so let me just see, okay, what we missed. Okay, so
that's it.
YF equal YI. Oh, probably the VIY is not 0. Because, you know, at this point, okay, I assume that, you know, it kind of horizontal, yes? But if it's not horizontal, the person, when it's reaching here, it will have horizontal velocity. The vertical velocity is 0. And YF equal YI 1 over 2 negative 9.8.5 second. H 1 over 2 negative 9.8 power of. So let me just redo this problem one more time. Okay, we have to redo this problem, okay, because we missed this part. Okay, so, okay, let me just take the screenshot. And then, okay, so just skip this one. Good. Let me just redo it. Okay, so, you know, the person was here, yes? I just use particle. Okay, what is the energy here? mgh. Good. We call this situation number 1. Situation number, the person is here and it does have velocity in this direction, yes? Okay, we call this number 2. What is the energy at number 2? It's gonna be mgh, yes, plus 1 over 2 m velocity is squared at 2. Good. And this person goes and hit the water here, yes? Good. And then let's say from here to here is 5 meter. Good. Okay. And it takes how many seconds to hit the ground? 0.5 second. Okay. So, and we call, and then when this object moving down, the velocity is going to be in this direction. Yes. Good. Okay, this is a V2, this is a V3. Okay, so what is the energy here? Energy at 3. It's going to be just 1 over 2 m velocity 3 squared. Good. So, use the coordinate system. I say here is x-axis, yes? And here is y-axis. Good. When is here at number 2, yes? And then at number 3. What is we call this I, this is F. Good. What is the initial position in x-axis? 0. What is the initial position in y-axis? No, h. It's h meter above the ground. You see? This is the origin. Good. What is the final position? 5 meter. What is the yf? 0. Good. So you remember those two equations that I wrote? Yes? Okay. So it's going to be xf equal xi plus vix t, yes? And then in the y, we have yf yi plus viy, yes? T plus 1 over 2 ayt squared. So what is the initial velocity in x-axis? I call it v2, yes? What is the final velocity? What is the initial velocity in y-axis? 0, yes? There is no initial velocity in y-axis, okay? Just the velocity is horizontal, 0. What is the initial velocity? What is the final velocity in x-axis? 0, yes? What is the final velocity in y-axis is velocity 3, okay? I'm going to use this information and plug it here, okay? And there are more equations. V final y, V initial y, yes? 2ay, yf minus yi, okay? Good. And there is one more equation. V final y, V initial y plus ay time t. Good. So, okay, tell me what the first one give me. Do I have xf? Yes. 5 meter, okay. 5 meter equal to what is the initial x? 0. What is the initial velocity in x-axis? V2. What is the time?
0.5.
0.5, yes? So V2 is going to be how much?
5 divided by 0.8.
5 divided by 0.5 is going to be, well, it's going to be 10, yes? 10 meter per second. Okay? So how about this one? Okay, what can I get from this one? I think I can get, H, yes? What is the YF? 0, yes? What is the YI? H plus. What is the VIY? 0, yes? Plus 1 over 2. What is the acceleration? Negative 9.8. How many seconds later it hit the ground? 0.5 seconds, yes? So calculate the h from here. It's going to be 1 over 2, 9.8, 0.5 power of 2, yes? Which is going to be 1 point. Okay, let me just calculate 0.5 times 9.8 times 0.5 power of 2, yes? 1.225, yes? Okay. H here is going to be 1.225 meter. Good? Okay. So right now I'm supposed to find this height, yes? Which two I should put equal to each other? I put this equal to the E2, yes? Okay. Because I have height and I had B2, yes? Okay, just calculate that. So let's say E1 equal to E2, okay? What is the E1? mgh. What is the E2? 1 over 2m velocity squared plus mg small h, lowercase h, yes? Okay, so what I can do here, I can factor m, and I can divide by g, divide by g, divide by g, yes? So h will be velocity squared over 2g plus h over g, yes? What is the velocity squared? Okay, 10 power of 2 divided by 2 times 9.8 plus, what is the h we calculated? 1.225 divided by 9.8, yes?
Yes.
Okay, just calculate this one at 100 divided by 2 times 9.8. Okay, the first term is going to be this value, okay? And the second term, 1.225 divided by 9.8 is going to be this value. Okay, now we are supposed to add these two values together, yes? Okay, this one,
0.23.
okay, plus second one, which is going to be how much? 5.22, yes. 5.23. 5.23 meter. Good. So 5.23 meter. So this, you see how important is to read the problem? We didn't read that just 5 meter, okay? So that's why we made a mistake, okay? So,
I read it at first.
okay, so probably it was
I was trying to do the kinematics.
okay. Okay, good. Okay, that's great. Okay, so, and I think we are done. Okay, perfect. Okay, we just did.
Thank you.
You're very welcome.